We're the SLAM team, and SLAM stands for simultaneous localization and mapping. The goal for SLAM is to use sensors to estimate the position of our robot and the obstacles. Besides the fact that SLAM is a huge system, the thing is, mapping needs to estimate the location of all obstacles, and it also depends on localization. This dependency makes SLAM very difficult. In MuddSub, it is hard to even get accurate distance data, adding on to the challenge. Of course, more challenge means more fun. In this sprint, we implement an algorithm named FastSLAM2. One feature that makes this algorithm special is that it reframes the problem and applies conditional dependence to the problem. It means that if we know the robot's path, we can treat individual obstacle estimation as independent. As such, we can get a much simpler but exact factorization of the posterior. To implement this algorithm, the big idea here is that we keep track of something called particles, which is a guess of the robot's position and the obstacle's location. Our goal here is to find the particle that is most consistent with sensor measures. Now, Chris will talk about the improvement of version 2.
So FastSLAM 2.0 improves over FastSLAM 1.0, which we implemented in the fall, by using sensor measurements when computing the poses of all those particles. So this improves the accuracy of the particle locations, and it also allows the algorithm to maintain particle diversity, which allows FastSLAM 2 to converge more quickly and with fewer particles. And this is especially true when the motion model is noisy compared to the sensor measurements. So on the right, you can see the result of our implementation on a data set. So while our localization is okay, there's still some bugs, especially with the landmarks. So we go on to our next steps. In the future, we need to continue debugging this. And so we plan to test the parts of our implementation by hard coding in information and seeing how the algorithm does in order to locate bugs. So for example, by providing the ground truth robot path to the algorithm, we can test how well the mapping portion of the algorithm is doing on its own. In the future, we also plan to incorporate MuddSub specific information to the algorithm, such as the type of obstacles like gates, buoys, etc., which will hopefully improve the accuracy of landmark recognition. And we also plan to integrate our code with other subsystems like computer vision and eventually get it to run in the simulator.